Yeah, it's officially the biggest midget in the game. I don't know. Make way for the insult.
Polymorphic behavior. In the example of commission employee class hierarchy, in which class base plus commission employee inherited from class commission employee, the examples in that section manipulated commission employee and base plus commission employee objects by using references to them to invoke their methods. We aim superclass references at superclass objects and subclass references and subclass objects. These assignments are natural and straightforward. Superclass references are intended to refer to superclass objects, and subclass references are intended to refer to subclass objects. However, as you will see, other assignments are possible. In the next example, we aim to superclass references at the subclass objects. We then show how invoking a method on a subclass object via superclass reference invokes the subclass functionality. The type of the actual reference object, not the type of the reference, determines which method is called. The examples demonstrate the key concept that an object of a subclass can be treated as an object of its superclass. This enables various interesting manipulations. A program can create an array of superclass references that refer to objects of many subclass types. In this is allowed because each subclass object is an object of each superclass. For instance, we can assign the reference of a base plus commission employee object to a superclass commission employee variable because a base plus commission employee is a commission employee. We can treat a base plus commission employee is a commission employee. As you will learn later in the chapter, we cannot treat a superclass object as a subclass object because a superclass object is not an object of any of its subclass. For example, we cannot assign the reference to a commission employee object to a subclass base plus commission employee variable because a commission employee is not a base plus commission employee. A commission employee does not have a base salary instance variable and does not have methods set base salary and get base salary. The is relationship applies only from a subclass to its direct and indirect superclasses and not vice versa. The Java compiler does allow the assignment of a superclass reference to a subclass variable if we explicitly cast the superclass reference to the subclass type, a technique we discussed in detail in section 10.5. We would be ever want to perform such an assignment. A superclass reference can be used to invoke only the methods declared in a superclass. Attempt to the invoke subclass only method to the superclass reference results in compilation errors. If a program used to perform a subclass specific operation on a subclass object reference by a superclass variable, the program must first cast the superclass reference to a subclass reference through a technique known as downcasting. Thus, this enables the program to invoke subclass methods that are not in the superclass. We show a concrete example of downcasting. Polymorphic behavior. This creates a commission employee tree object and assign its reference to a commission employee tree variable, assigning superclass and subclass reference to it to superclass and subclass variable. To assign superclass reference to superclass variable, then assign subclass reference to subclass variable. After that, invokes toString on superclass object using superclass variable and invoke toString on a subclass object using subclass variable. Finally, invoke toString on subclass object using superclass variable. Pointers to base class. One of the key features of derived classes is that the pointer to derived class is type compatible with the pointer to its base class. Polymorphism is the art of taking advantage of this simple but powerful and versatile feature that brings object-oriented methodologies to its full potential. We are going to start by rewriting our program about the rectangle and the triangle of the previous section, taking into consideration this pointer compatibility property. In function main, we create two pointers that point to objects of class C polygon, then we assign reference to rect and trg1 to these pointers. And because both are objects of classes derived from C polygon, both are valid assignment operations. The only limitation in using p-poly1 and p-poly2 instead of rect and trg1 is that both p-poly1 and p-poly2 are of type C polygon, and therefore we can only use these pointers to refer to the members that C rectangle and C triangle inherit from C polygon. For that reason, when we call the area members at the end of the program, we have had to use directly the objects rect and trg1 instead of the pointers p-poly1 and p-poly2. In order to use area with the pointers to class C polygon, this member should also have been declared in the class C polygon, and not only in its derived classes, but the problem is that C rectangle and C triangle implement different versions of area. Therefore, we cannot implement it in the base class. This is when virtual members become handy. Abstract base class. Abstract base classes are something similar to our C polygon class of our previous example. The only difference is that in our previous example, we have defined a valid area function with the minimal functionality of objects that were class C polygon, like the object poly. Whereas in an abstract base classes, we could leave that area member function without implementation at all. This is done by appending equal to 0 to the function declaration. An abstract base C polygon class could look like this. Notice how we appended to 0 to virtual int area instead of specifying an implementation for the function. This type of function is called a pure virtual function, and all classes that contain at least one pure virtual function are abstract base classes. The main difference between an abstract base class and a regular polymorphic class is that because in abstract base class at least one of its members lacks implementation of, we cannot create instance objects of it. But a class that cannot instantiate objects of is not totally useless. We can create pointers to it and take advantage of all its polymorphic abilities. Therefore, a declaration like C polygon poly would not be valid for the abstract base class we have just declared, because tries to initialize an object. This is so far as long as C polygon includes a pure virtual function, and therefore it's an abstract base class. However, pointers to this abstract base class can be used to point to objects of derived class. Polymorphism through interfaces. Interfaces define the standardized ways in which things such as people and systems can interact with one another. Software objects also communicate via interfaces. A Java interface describes a set of methods that can be labeled on an object to tell the object to perform some task or return some piece of information. For example, my next example introduces an interface name variable to describe the functionality of any object that must be capable of being paid and thus must offer a method to determine the proper payment amount due date. An interface declaration begins with the keyword interface and contains only constants and abstract methods. Unlike classes, all interface members must be public, and interfaces may not specify any implementation details, such as concrete method declarations and instance variables. So all methods declared in an interface are implicitly public abstract methods, and all fields are implicitly public static and final.